Hello, I'm Stephen Morey, and together with Craig Cornelius, we'll be presenting about connecting the dots with Unicode, bringing Unicode to life in Assam. And we're going to be talking about two particular scripts, the different scripts of the Tai languages of Northeast India. So we'll introduce the Tai languages, then we'll talk about the encoding of the Myanmar blocks, because some of the scripts are encoded as part of the Myanmar system. Then we'll talk about the encoding of Tai Ahom, and then we'll discuss current challenges to do with fonts, keyboards, rendering in different programs and on different devices, and delivering all this to the users. Okay, so as a background to this, it's important to distinguish two different types of scripts that are being used in Northeast India by Tai-speaking people. There are the various Tai-speaking groups, the Khamti, the Phake, the Aiton and the Khamyang, and there's also a group called the Tai who nowadays speak a Singpo language, but who use traditionally the Tai script, and they all use very similar scripts, which they would call To Lik Tai, meaning Tai letters. And this script is based on Shan, and it's encoded as part of the Unicode Myanmar block. These languages are mostly still spoken, although as I mentioned before, the Trung people now speak Singpo mixed with Tai language. But some of the languages are quite endangered, and the script is certainly not used by most of the people who speak the languages in a particularly deep way. We'll talk a little bit more about that later. The Tai Ahom is a different community who have not spoken their language as a mother tongue for 200 plus years. They have their own script, separate script that has its own block within Unicode. We could say that until very recently, all of the scripts of Northeast India are unreformed Tai scripts. And what I mean by this is that they have not yet added symbols for vowels and additional consonants and indeed tone marks that have been added in some other scripts. But there are moves afoot to do this, and this will lead over time to alterations in those scripts. So let's be sure about the part of the world we're talking about. This is Northeast India, which is the section marked in red on the map on the left. And it is surrounded by Burma, Bangladesh, Tibet, and has only a tiny little chicken neck, as it's sometimes called, that links it to the rest of India. It's divided into 7 states, and there are a significant number of Tai people living in Upper Assam, that's the sort of right-hand part of the green-coloured state, and also across the border in Arunachal Pradesh. Okay, so the Khamti, Phake, Aiton, and also Khamyang people, and the Tai as well, use this To Lik Tai script. And here's an example of it, a manuscript owned by Jao Nikhang at Borhola village, Tai Aiton village. The manuscript is called Chatupatan. That is a translation of, or a reinterpretation perhaps, of a Pali script. And this manuscript clearly demonstrates the difference in characters between the Burmese on the top line, that's the Namo Tassa, the salutation to the Buddha and others, that goes on the top of any of these manuscripts and is shown without these large black dots. But once the Tai language begins, Ken, Pen, Ni are the first 3 words, Tam. Once the Tai language begins, you can see these very large and distinctive black dots which differentiate the Tai script from the Burmese script. This becomes an issue later on when we talk about the encoding and the need to access variants. Okay, so these scripts are endangered. They were traditionally taught in Buddhist temple schools. So it would mostly have been boys traditionally who learned them, although these days there are quite a lot of women who have learned these scripts, but they have mostly taught themselves. The temple schools do still operate in some sense, but not as effectively as before. So many of the people who are learning the script these days are doing so as individuals, and there is not an organized school teaching of them. A key difference between these scripts and Roman scripts is that they underspecify what we would call the phonemic distinctions. So if we look, for example, at the Thai form ma, the ma symbol followed by the R symbol, and I've given you that form in script, this can mean horse, dog, come, shoulder, and various other things. And you can't tell what it means by writing this word up, say, on a blackboard or putting it on a screen, in the way that you can with the English word horse. Horse is transparent. It has some extended meanings, but we will all know immediately what it means. The Thai equivalent word does not convey that. It would be a little bit like all the words in English being like bear, B-E-A-R, which both refers to an animal but also means to carry. But in the Thai languages, basically every written word that you can write has multiple meanings, and some of them have a significant number of multiple meanings. In order to read an old manuscript like the Chatupathan that we saw on the previous slide, you need to know all the possible meanings of all the different written words that you're looking at and work out from the context which is the appropriate meaning. There's comparatively few people that can do that, and in the Thai languages of Northeast India, the most endangered feature is the ability to read and interpret the traditional manuscripts. But there are people working on this, and here we have a photograph of Sao Kyo, who has recently been awarded in 2019 a national award in, and I quote, recognition of her remarkable contributions to the upliftment of the downtrodden peoples of India. And she's been working at translating some of these traditional manuscripts into Assamese and in making sure that old manuscripts which have perhaps become damaged over time in their temple library get copied anew. Okay, so that's the Tai Phake, Tai Aiton, Tai Khamyang. There's also the Tai Ahom, a language that hasn't been spoken as a mother tongue since about 1800, but is undergoing a revival. Here's a traditional manuscript, a very beautiful one that belonged to the late Junram Sangbun Pukon, a very dear friend of mine from Parijat village. And we've got some good photos of it, which is really good to have. Beautiful painted manuscript made on the bark of a particular tree, which is called the Hasi in Assamese, and I've forgotten what its scientific name is. Okay, the Ahom alphabet has this set of consonants. It's possible that there's around 1 million people, or 10 lakhs if we use Indian English, who identify as Ahom, or possibly more. And as a result, there has been work to revive this language for a century or more. But as part of that revival, the community are thinking about the need to add additional symbols that were not present in the original language. I just want to make a point before handing over to Craig about the difference between different views of the same glyphs. So what insiders in the community feel as being the same or different may not be the same as what members of the Unicode committee or font developers feel, and academics may have a further view. So, as an example, these two symbols for the general reader are regarded as the same. One is the italic version of the other. But for linguists trained in the IPA script, these two symbols have different sounds. The first one is a more front vowel, a bit more like ah, perhaps. The second one is a back vowel, a bit more like or something like that. I can't actually pronounce either of these sounds to the perfection, but people who are trained in phonetics very well will be able to differentiate these two and will regard them as separate sounds and separate symbols. And there are languages where you need these two symbols to distinguish vowels that are not the same. So it is, in my view, with these three symbols. So what we see here on the left is the Burmese ta. This is taken from the Chatupathan manuscript that I just showed you. Then we have next to it the Tai Ta, that's T-A. This is taken from the same manuscript. And then we have the Ahom Ta on the right. And many members of the community in Northeast India, and frankly me too, would regard these as three different symbols. But the fact is that for reasons that we could discuss, the first two have been encoded in the same location, and you can only get the middle one via variant selectors, whereas the third one, the one on the right, has been encoded separately. Yes, there are differences between them, but from a community's perspective, these three would be kind of equally different. Okay, so what does the community want? Well, for the Khamti, Phake, and Aiton community want to see their script with the black dots. So this is a font that I made back in 1997. It's not a Unicode font, but what people often get these days is something that looks like this, which people have said to me is not our script. Now we are moving towards a kind of middle ground on this. So community members are getting used to the fact that for the moment they may have to type without the dots appearing until we get those variant selectors to work. And we are working to get those variant selectors to the work. But over the last couple of years, whenever I've suggested this, people have said that is not our script, even though the encoding of the part at the bottom right is exactly what you would get without variant selectors encoding the piece of script that it's at the top, which is done with the pre-Unicode font. So the challenges, well, there probably never will be anyone who understands all the issues involved in this, both from the point of view of knowing the languages, knowing the script, knowing the literature, and also all the technical issues of encoding, implementation, font design, keyboard design, updating platforms, browsers, etc. So you can see at the bottom the quote from Jaukalingna Manoy, a member of the Khamti community, who wrote to me a few weeks ago that what they want is to be able to see the forms with the dots without needing to install some extra programs, etc., to get these to work easily. Okay, now I'm going to hand over to Craig and move to the next slide. Craig, welcome.
Thank you, Stephen. Just a little bit of background on the Myanmar writing system. It has been in Unicode for a long time. In 1999, the basic block was added, and two extensions have been added in Unicode 5 and 5.1, and later in Unicode 7. And those additions added basic support for these languages, including other languages as well. So there are actually quite a few different characters which are not used for writing basic Burmese, but are used for writing other languages that use this script. Next slide, please. However, Unicode does not specify the exact shape or style of particular characters. Unicode characters are abstractions, just like the letter A in English can be represented with many, many different shapes depending on the font and the style someone wants. The font is what typically determines the specific shape used in a presentation to someone on the screen or in print. But as Stephen said, the community members may reject the text that doesn't use the particular style that they expect. This is seen very often with people who are relatively new to using their languages with technology. In particular, the dotted forms are strongly preferred by Myanmar script, so that the top line there shows a series of characters in a dotted form of the font instead of the lower form. They're exactly the same characters in Unicode, but they're displayed differently. Now, this can be handled by people who are using their computers, desktops and laptops by simply installing a font that has the right shape of each of the characters exactly as they like it, and then applying that font in documents that they're going to be used for sharing with each other on screen and in print. However, this is very different from the world of online use. On websites, usually people do not specify a font, or if they specify a font, it's a web font, they can't change it. And on mobile devices, it's especially important because people can't change the font that's applied to the text they're viewing. So social media, blogs, and so many other places will not show the text people want, and they have no way of changing it. Next slide, please. Now, there are several ways that this could be handled. One way would be to just simply encode new characters for each of the shapes that are needed. And this approach has been taken with some writing systems. However, in this particular case, the Unicode committees decided that the characters are actually the same as the Myanmar script characters that have already been encoded. And in 2016, a new mechanism was added to handle the cases in Burmese script and other scripts to deal with difficult edge cases. And it's called variation sequences. Variation sequence is simply the idea that you add some special codes after a character that tells a font to display a different glyph from its set of pictures that it has for the particular character, if that is available in the font. If the character is not available in the font, it falls back to the standard form. It's really important to note that this concept of variation sequence is standardized in Unicode. One can't just say, oh, I want to put dots on any particular character. The Unicode standard has a mechanism for this. People suggest and write proposals to the Unicode committees. If they are accepted as variants, then they go into some files which define what standardized variants are. And this is both for alphabetic and symbolic characters, as well as the ideographic characters, which are typically found in Chinese. Now, most variation sequences have been defined for using with math symbols, such as 0. We don't think of 0 as having different forms, but some people like to write it as a round shape with nothing across it. Other people prefer to have a round shape with a diagonal slash through it. This can be selected in fonts that include that variant with a selector that says use the slash form. Different emoji also can use variant selectors. Many characters in Chinese and in Myanmar and other scripts can use these as well. It's a fairly small set that use variation sequences, but it's important to note that for a particular character, up to 16 variation selectors could be applied. So up to 16 different shapes can be standardized within the Unicode. Next slide, please. Now, the variation selectors are essentially part of the text. They are portable. They're part of the text that's actually written up to a file and retrieved when someone loads the file again, which is different from the idea of applying a style in an application, such as a superscript or bolding, because the variation sequences then become portable. One can copy the variation sequence in one application, paste it into another sequence, into another application. And if that application is capable of handling variation sequences, then the characters will be shown properly. Text searching and matching ignores variation selectors in almost every case. Unicode libraries provide that capability. And it's even possible to mix text that uses variation selectors with text that doesn't. So it would be perfectly possible to put in Burmese text without the dots and then use Burmese or the Myanmar script characters with Phake or one of the other languages that would have variation selectors in the same document with exactly the same font. The difference is some are marked to use the variation selectors. But there are some things that are needed. Modern fonts need to be available in the computer system, and the rendering software has to be smart enough to apply the variations in the font to producing the pictures on the screen or in print. And someone has to be able to add these variation selectors to text. Now, it could be done manually, but that would be very awkward. The better idea is to actually have a keyboard that is specialized for the language that you're using. So a Phake keyboard would know that particular characters would put the dotted form in. In other words, when a character is typed in those, it would add the variation selector immediately after the characters that need it. There are another disadvantage is that it increases the size of the text data, because basically for every character you're putting in, you're adding another invisible modifier character. And the biggest disadvantage is that some applications don't understand variation sequences yet, because honestly, not that many people have actually used them. So at the upper right, I show a couple of different fonts. Both of them happen to be Noto fonts that differ in weight and differ in style. One is serif and one is sans serif, but they are exactly the same characters, just rendered with two fonts, and they show the dotted forms. Down below is incomplete support by a font, Padauk, which doesn't know about all the dots that are needed. Next slide. So there's currently a lot of work needed to support variation sequences. First of all, mobile devices need to have variation sequence fonts. In other words, older fonts that didn't have this variant shape maybe on older phones, and the rendering software may not be up to date for this. And current work is developing a proposal to the Unicode technical committees to add additional dotted forms to more characters, so that this would effectively extend the variation sequences that are supported for the Myanmar script. This would also require then to have all the Noto fonts updated for these languages, and Mitchell is working on that along with Norbert Lindenberg's work on developing the proposals. And Stephen and I are collaborating on developing Keyman keyboards in prototype form now that people will actually be able to use. These keyboards actually include the variation selectors. Next slide.
Okay, so as mentioned before, the Tai Ahom was encoded in a different block. I've given you the link here to the, I think it's the original proposal. This was submitted in 2012 and approved and was released in Unicode 8. Another character was added in Unicode 11 in June 2018, and we currently have a proposal to add 7 more characters for the publication of the World Tipitaka in Thai Scripts 15 script set. So this was an attempt to render the entire Tipitaka, the Pali Buddhist holy books, using the Tai Ahom script. And so that all of the consonant distinctions found in Pali language could be expressed, this required the creation actually of 8 additional Tai Ahom letters, but they only created 7, leaving no distinction between J and Y, or between Ja and Ya. This is currently before the Unicode as a proposal to add these letters, for which we have evidence. Okay, so I have recently been talking to the community in Northeast India and explaining to them and discussing with them that making the scripts work for them is more than just getting things included in Unicode. So everyone in Northeast India is really pleased that all of these scripts are now present in Unicode, but actually accessing them is something more. So this is not telling anybody here things that you do not know, but these stages are not necessarily understood by the community. So 1, we need to include in the Unicode standard. 2, we need to develop the fonts. 3, we need to develop the keyboards. Then we need to update the operating systems on all the various devices that we use, as well as possibly updating applications to support the script or new characters. And this may mean installing fonts and keyboards on devices, or enabling individual applications such as Word, browsers, and other applications to recognize the fonts. You'll see some examples shortly of this not working. And we need to also make the point that cell phones as they are usually called in India, or mobile phone, as I would call it here in Australia, usually doesn't allow, it probably should say usually does not allow the users to install fonts. And this means we have to wait until the fonts are part of the cell phone's release version. So every time we make a change at the Unicode standard, all these other points, 2, 3, 4, 5, and 6, also have to be updated. And that's going to take a little while, not to mention the issues with the variant selectors that are there before. And as everybody knows, there is need for revision to the Unicode standard from time to time. And in connection with the scripts we're talking about today, this can involve both when we identify new symbols in traditional manuscripts. So there's a discussion going on at the moment about some numerals in Tai Khamti that are not currently encoded, and collecting evidence for those and what forms they should take. And then, because language revival is going on, and that language revival or revitalization of spoken languages may involve script reform, things like adding additional consonants or adding vowels so that all of the vowel distinctions in the spoken language are reflected in the written language, and adding tone marks. I mean, we know, for example, that English has many more than 5 vowel sounds, but only has 5 vowel symbols. And the way that we write those other vowels is, well, that would be the matter for a whole other very long talk. But what some of these communities are doing, it's already been done for standard Shan in Myanmar, is to add additional symbols to cover these vowels that are present in the spoken language but were not traditionally present in the written language. And there can sometimes need to be changes for the combination of diacritic marks. Now, this is an example, and I apologize for not putting the Unicode numbers for these 3 symbols in Tai Ahom, which is G followed by KA, followed by the R vowel, double A vowel, and followed by the killer. And this would not have been possible in some earlier versions because there was not an indication to both the font and through the Unicode that you could combine the killer on top of the R vowel. Now, it does work, but this is not something that I've typed directly into PowerPoint. Okay, so I wanted to give some samples of the implementation, that should say, of the Noto fonts. And this I wrote in LibreOffice Writer a couple of weeks ago. And we can see here one small problem, because in the Noto serif Ahom, for some reason, for a particular reason, there's that little dotted circle, and this is because the system has not accepted the fact that the final symbol, that what's called the killer, can follow the vowel O. Now you'll notice that I have written those symbols with a different font in my script on the right-hand side than I have written using LibreOffice Writer. The reason for that is that the part on the left of the screen is a screenshot of LibreOffice Writer. Note that the current version of Word that I'm using implements the Ahom correctly, completely, but does not allow the variants of Tai. This can be quite confusing for members of the community, well, for me too, as to why this happened. Now, the next slide shows you what this looks like when I tried to type it into PowerPoint. So I can't actually use any of these scripts the way I would like them to look in PowerPoint at the moment. And I'm very grateful to Andrew Glass and Stephen Chua, amongst others, who are looking into why these fonts are not working in PowerPoint, at least in the version that I currently have. So this is a very good example of the implementation problem that we have. So this is really difficult for members of the communities to come to grips with. And I think this is an important take-home message from this talk. Why, if the font is correct and the keyboard is working, does it still not implement? So Craig, I'll hand over to you.
It's important to note that this work with variation selectors is relatively rarely implemented. And as I discussed before, the variation selectors are one way of dealing with this. It's a different way of dealing with it than encoding completely new characters. Here's an example that shows the same line with, I've added the V colon to indicate the variation selector line, and the N means no variation selectors. The little keyboard symbol here is actually something from a website that I use to build this prototype keyboard, and you can see the dotted forms in the keycaps there. Each of those characters needs to be typed with a Phake keyboard that puts variation sequences in it. And below the code points on the left, you can actually see that each of the regular Myanmar script characters is followed by FE00. FE00 is the code for the first variation selector that's used with these particular characters. Font has to implement the variation sequence for dotted forms in order for them to show. So there are two problems: typing and the fonts not being completely ready for the display of these characters. Next slide. Implementing the fonts in the keyboards involves all pieces working together. The fonts have to be on the device, the input methods have to be developed, and rendering software has to be ready as well. There are many cases where we have fonts and the characters all set, but the rendering system isn't quite up to handling the forms of the characters properly. And delivering all of these to every device is the hard part. For desktops and laptops, it's actually easier because most desktops and laptops allow people to install their own fonts, and people can either get keyboards from the operating system vendors or from other sources such as Keyman. And many applications will just work when the font is selected for the particular text being typed. However, some fonts that are already or that are not included in the provided operating system may not work in every one of the applications. It's been noted that different applications on a Windows machine will deal with these in different ways. But what is particularly annoying is that fonts are very hard or impossible to install on many mobile devices. And this is due to security and privacy issues with mobile devices, and basically it's just not done. In addition, the rendering software may not be up to handling things like variation sequences. Back to you, Stephen.
Yes. So I just wanted to go through another example of some of the tricky issues that we have. So I tried typing the message, I'm going to eat rice in several languages, and I've already spotted an error in the Thai version. And when I type this on Facebook this morning, you'll see that the Ahom comes out with tofu boxes. The Noto Sans Wancho comes perfectly. The Myanmar one doesn't implement the dots, and that's because I had selected Noto Sans Wancho as the default font on Chrome. As soon as I shift that default font to Noto Serif Ahom, I get this. The Ahom now works almost correctly, but again, there's that same problem with the little dotted circle, and that's because at some point, it's either in the application or in the font, isn't sending the message that the vowel below and the killer above can be combined, but now the Wancho has turned into tofu boxes, and the Thai languages are still showing without dots. And when I change it across to Noto Serif Myanmar, I get the Noto Serif Myanmar showing correctly, although there's actually a vowel missing there, so that's my problem. I didn't enter the data properly. But the Ahom and the Wancho have gone to the tofu boxes. Now, for those attending this conference, when you see the tofu boxes, you'll know that something is there and that this is an implementation issue to be fixed, and you'll probably be able to work out how to fix it. But for community members, when they see this sort of thing, they are most likely to give up because they don't know how to begin to deal with this, and it's just too hard. So back to you, Craig.
Another challenge of dealing with languages that are relatively new to the internet is that very often there are old texts that people would like to share. But usually people have developed these texts using font encodings, which basically are replacing the shapes of characters in a normal font like like Times Roman or other fonts, and replacing the shapes of A through Z with their own characters. To use these texts in the Unicode world, there needs to be some sort of conversion. So on these websites that are pointed here, we've actually implemented a few converters to take Tai Ahom, Tai Phake, and Tangsa fonts, Tangsa text in pre-Unicode format, and running a set of rules, they can be converted to actual Unicode fonts. And so on the right, you see an example in old Tangsa font going to Unicode Tangsa font text. The converter programs have several things to do. They have to transform individual code points to the Unicode values. They often have to reorder the vowels and diacritics, which without that, very often people get the dotted forms showing that the characters aren't, or the diacritics aren't in quite the right order as expected by Unicode. And this tool allows people to take text, paste it into a region on these websites, and then get out the Unicode text that they can then copy and paste into other applications. Of course, this isn't very satisfying if one has a big Microsoft Word document or a PowerPoint or something else where it would require lots of copying and pasting. And so I have built several programs that will take these Microsoft formats and others and convert them into Unicode output, basically looking for where the old font is. They're running the conversion on that section of the text and putting it into the right context. So properly formatted Microsoft Word documents come out of this. And this can be extended to other file types and other font encodings. And I've made it so that it's not too hard to add another language to do these conversions for full files as indicated here. Next slide. Here's an example with old Tai Phake data. The data appears with the encoding form using the dotted forms because that particular font was put in with the dotted forms. Converting this to Unicode can produce the dotted forms, and this particular font is Myanmar Serif Light. It's also possible to take existing text that does not have the variation sequences in it and tell the program to add the variation sequences so dotted forms can be added. And if someone wanted to, they can remove the dotted forms by removing the variation sequences in this particular tool. Stephen?
Yep. Okay, so we'll finish by saying that the future is looking good. So late last night, early this morning, in Australian time, 22nd of September here in Australia, I received a message from Yin Khamyang, which you can see here, that announced that her father, Ailot, who has been working for many years on the Tai Phake dictionary, has worked out how to install the font and the keyboard that Craig has created. And so she was able to type a message on her mobile phone, and using the font, the Noto serif font, or one of the Noto fonts, and using the keyboard that Craig has created. When she says we wholeheartedly thank you, I want to extend this to a wholehearted thanks to Craig, but also to everyone from the Unicode committee and all the people, many of whom we've named in this talk, Ben Mitchell, Norbert Lindenberg, Andrew Glass, Debbie Anderson particularly, many others who behind the scenes are working to make all of this possible. So we were very pleased that on the very day that we've put this talk together, we get a really hopeful message from the community. So question, what next? I think we'll stop here and allow some time for discussion. So thank you.